Geometric series has first term 4 and then common ratio r. So the next term is going to be 4r, then 4r squared, then 4r cubed. And we're told that r is between 0 and 1. So that means it's going to be a convergent sequence, and hence we can find the sum to infinity in a minute. We're then told that the first, second, and fourth terms of the series form 3 successive terms of an arithmetic series. Okay, so we don't know if they're the first term in the arithmetic series, but that's not going to matter. We just know that we're going to have some sort of sequence, and then it's going to be 4, 4r, and 4r cubed in the mix. And we're basically being asked to find out r, and then we can find the sum to infinity. So to get the difference, right, we're adding on a common difference every time. To get that common difference, you just take terms away. So 4r minus 4 would give you the common difference. But so would 4r cubed minus 4r. The third, well, it's not the third term necessarily, but this one minus the 4r, yeah. So that they must be equal. I'm not going to bring d into it any more than that, except to just say that, yeah, those two must be the common difference. And that gives us an equation in terms of r, which we can now solve. So 4r cubed minus 8r plus 4 is going to equal 0. Going to divide through by 4. R cubed minus 2r plus 1 must equal 0. Okay, and I think now we've got to try and put a value in to get 0, use the factor theorem. And it's got to be 1 or minus 1 if it's going to work. So if r is equal to 1, then r cubed minus 2r plus 1 is going to be 1 minus 2 plus 1 is going to be 0. So therefore, r minus 1 is a factor. You could do a polynomial division, but I think we're on a roll. Let's just try and factorize it. This is a little bit quicker, this idea. So if it's going to factorize, we're going to have an r squared there. We're going to have a minus 1 there. Then it's just a case of making sure we don't get any r squared terms, but we do get a minus 2r. So to avoid an r squared term, right, I've got a minus r squared here, so I need a plus r here to give me a plus r squared and cancel them out. So I've definitely guaranteed there's no r squared. Let's just check that we do get minus 2r. Well, I'm going to get minus r, and I'm going to get minus r, so all is good. So either r equals 1, or, because this doesn't factorize nicely, r squared plus r minus 1 equals 0. By the way, we're going to reject this one because we were told at the start that r had to be between 0 and 1. So let's solve this using quadratic equation. Minus 1 plus or minus b squared, that's 1 minus 4 times 1 times minus 1, that's going to be a plus 4, square rooted all over 2. So minus 1 plus or minus, actually, let me write them separately at this point. Minus 1 plus root 5 over 2, or minus 1 minus root 5 over 2. That one's going to be less than, what was it we're told? It was between 0 and 1. Okay, that one's definitely going to be less than 0, so I'm just going to reject it. Okay, and we're nearly there because we have our first term of the geometric series is 4. Right back at the beginning we were told that. And the common ratio is then root 5 minus 1 over 2. So my sum to infinity, which is a over 1 minus r, is going to equal 4 over 1 minus root 5 minus 1 over 2. Going to times top and bottom by 2 to give me 8 over 2 minus root 5 minus 1, which then becomes 8 over 3 minus root 5. And now you can see in the answers they've rationalized the denominator. So just got to do that, bring it around here. So I'll get 8 times 3 plus root 5 all over, I'm timesing top and bottom by 3 plus root 5, 9 minus 5 I'll get, which becomes 4 on the bottom, so I'll get 2 times 3 plus root 5. Nice question. That is the sum to infinity, 2 times 3 plus root 5, which is D.